All right, 10.2, we're going to continue with the graphs of quadratics. So it says how can you tell which way a parabola is going to open? So when A is positive, okay, A is positive, it opens up, which makes your vertex a minimum. And we're going to keep working with that today. When A is negative, it's going to open down, which makes your vertex a maximum. Okay? All right, so all is well and good. You understand where they open and such, but I gave you the numbers to plug in for X on your exploration, which means that I made sure that you had the vertex included in the middle, and then I gave you some points to the left and some points to the right. But how did I know where the vertex was going to be? And that's what we have to figure out today. It's not like a line where it's just okay to plot any 3 points and graph your line because it's just going to keep going in that same slope. It is a U, so you have to know where it makes that turn so that you can graph it appropriately. So we're going to focus on finding that vertex today. So where is that highest point or lowest point or that middle point, so then we can kind of figure out where we need to go from there. So all parabolas are symmetric. So you can fold them in half and they're going to be the same on each side. Now, if you go to your exploration from yesterday, you can cut all your parabolas in half. What I want you to notice is when you chop them in half, every time you chop them in half, you're drawing this vertical line that goes through your vertex. Okay, the whole point of chopping them is to go through the middle, and your vertex is in the middle. So your line that chops at your line of symmetry, axis of symmetry, always goes through your vertex. And it's always a vertical line. And the equations of all vertical lines are x equals a number. Okay, so if you remember, vertical lines only have an x, horizontal lines only have a y, and then the normal lines have x's and y's. But we are just talking about a vertical line through your vertex, so we need that x value. Also, if it goes through your vertex, then it's going to have the same x value as your vertex. So we'll get there, but it's all connected. So the way that we're going to find it is with this equation, negative b over 2a. And we talked about how quadratics are ax squared plus bx plus c. I'm going to force you to still find a, b, and c. I understand that this equation only has b and a, but we're going to need c pretty soon, so we're just going to get used to identifying a, b, and c. And then we're going to plug them in to negative b over 2a and find the axis of symmetry, that line that chops it in half, which is also going to be the x-coordinate of our vertex. Okay? So we find a, b, and c, find the axis of symmetry, negative b over 2a. Okay, this is getting very important. Then that's your x value of your vertex. Your vertex is a point. Your axis of symmetry is a line, so you need to write it as an equation, x equals a number. Then your vertex is a point, an ordered pair, so you need it with an x and a y, like this. You already know the x because it's the same as your axis of symmetry, and then you plug it back in to get the y value. So these are all the things we need. So let's try to figure out what we got. A is the number in front of your x squared, which in this case is negative 3. B is the number in front of your x. Take the sign with it. It is negative 6. C is the number by itself, which is just going to be a positive 4. So there's A, B, and C. Our axis of symmetry is x equals negative b over 2a. That's how we're going to find it. So x equals, this first negative is part of the formula. You need it every single time, negative. And then put parentheses because we're making a substitution, and then plug in what we found for b. b is negative 6 over 2, put parentheses because we're making a substitution, and then a is negative 3. Okay, from here we are simplifying. So a negative 6 is a positive 6. 2 times negative 3 is negative 6. So 6 divided by negative 6 is negative 1. That's the equation of my axis of symmetry, AOS, axis of symmetry, because it's a line, a vertical line, and it needs to be written as x equals. That has to be the case every time. That x is two things. It's my axis of symmetry, and it is the x coordinate of my vertex. So I'm going to use it and plug it in just like we did during the exploration yesterday to find my y value. So -3, I know the x I want to plug in is -1 squared minus 6 times -1 plus 4, okay? I'm doing all of that to find my y values. That's exactly what we did yesterday. And then we're using this, to find the vertex. Okay, so then you put it in. So -3, parentheses, -1 squared minus 6 times -1 plus 4. And we get that y is 7. Your vertex is a point, an x and a y. The x I plugged in was -1, and my y I got was 7. So I have my axis of symmetry, AOS, and now I have my vertex. The last thing I want to do is I want to know if that vertex is my highest point or my lowest point. And the way I figure that out is I look at my original equation. My a value was negative. So since a was negative, my graph opens down, okay? And when my graph opens down, that vertex is at the top. So this is my maximum. It's the highest point. Okay? So those are the three things that you have to do for your assignment. Identify your axis of symmetry, your vertex, and whether that vertex is a maximum or minimum. All right. Start over. A, B, and C. A is the number in front of the x squared, which is 1. B is the number in front of the x, which is 2. C is the number by itself. We don't have one, so C is 0. Okay? We need to use the equation x equals -b over 2a to find our axis of symmetry. So x equals negative as part of the formula. My b is 2 over 2 times a, which is 1. Simplify it. That's a -2 over 2. So x is -1. The x equals, that equation is my axis of symmetry. That's one of my answers, one of my 3 answers I need. Then I use it to plug it in to find, I'm going to move this over here, to find the rest of my vertex. That's half of my vertex. I need to find the rest of it. So I'm plugging in -1 squared plus 2 times -1. Okay, so you just put it in just like you did before, and we get -1. So y is -1. So my point, my vertex, my x was -1, and my y was also -1. Okay, that's my vertex. And then the last thing I need to know is if that's a maximum or a minimum. So I look at my a value. A is positive, which means it opens up. That puts my vertex down here as my minimum. And those are my 3 answers. Axis of symmetry is just x equals a number. My vertex is a point, x and y, and then maximum or minimum based on whether a is positive or negative. All right, we'll do one more. A is 1, B is 4, and C is -9. I need a -b over 2a, so negative, my b is 4 over 2 times my a is 1. That's a -4 over 2, which is -2. So x equals -2. That vertical line chops my parabola in half. So that makes it my axis of symmetry. A also is going to be the x-coordinate of my vertex, so I'm going to plug it in. So -2 squared plus 4 times -2 minus 9. So -2 squared plus 4 times -2 minus 9 is -13 as my y value. So I plugged in -2 and I got -13. So that point together is my vertex. And then I need to know whether that is my maximum or my minimum. My A is positive. That means my parabola opens up, putting my vertex at the bottom. That's it. You can do that one. And then 10.2.